Hi there. Thanks for joining us again. This is Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley, your host. Coming up on this episode, we'll be looking at Venus. Well, not specifically Venus. We'll be looking at a moon, or a quasi-moon, if you like, that seems to be orbiting Venus, but it's not. And what's even more mysterious is its name, which has got a funny story behind it. And we're going to try and figure out where all the sulfur is in the universe, because there doesn't appear to be enough of it, but it could be actually right in front of us and we can't see it. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Joining me to solve all of those riddles and puzzles and names of quasi-moons is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing?
I am well. I hope you're getting better after your long stint with insect bites. Not much fun at all.
No, it's the fever that follows them that's the bit that's not fun. And it's quite serious. So it's taking some time to shake off, but I think we're sort of on the mend and we'll see.
Yeah. Isn't it amazing how such a tiny creature can cause so much trouble? It's, yeah.
It is, yeah. The ticks that cause this, they're minuscule. You don't really see them properly unless you look through the microscope behind me there. That's what I've often looked at ticks in through that before and thought, they're an ugly little perisher.
You don't really want to see them close up, do you?
No, that's right. Yeah, it's because of the damage.
Can you imagine if a tick was the size of a dog or an elephant? No, thank you.
Yeah, no, thank you. Yeah.
All right. We will, well, obviously everybody's wishing you well, Fred, and hopefully you'll get better soon. We better get down to it. Let's first up talk about this discovery. It actually dates back a few years, this one. There was a seemingly innocent asteroid that's now turned out to be something unique, and it appears to be orbiting Venus, but that's not actually the story. It's acting in a peculiar way. What's going on with this one?
It's basically an object, an asteroid, a small asteroid. I'm not sure of its size. I don't think it's very big, and it's sort of gravitationally locked between the sun and the planet Venus. We've got a similar thing actually connected to Earth, Andrew, that you and I have spoken about before, an object called Grünia, which was discovered by an old friend of mine, Duncan Waldron, when he was an observer at the UK Schmidt telescope here in New South Wales, when I was working there too. And so that object was discovered there. And it's got a kind of very strange banana-shaped orbit, sort of centered on the Earth itself, but is actually in orbit around the sun. So this is something very similar. And the discovery story is, I think, quite interesting. I think it obviously goes back to 2002, as we'll discover in a minute, when it was actually discovered. But basically, a number of a number of astronomers have followed up on this over time. I think the original discovery was by Brian Skiff at the Lowell Observatory in Arizona. But it certainly has been followed up by astronomers at Tuelo Observatory, where I've been, which is in Finland, and also the University of Western Australia, and found that this is the first time something like this has been recorded in connection with the planet Venus. We've seen them with Earth, in fact, not just one, not just Grünia, but others, so they basically they followed up on this, but then the story switches to basically the story of what its name is, because
Yes.
things have gone slightly awry there. These scientists did note that this object will not stay gravitationally in the position that it is, or the strange orbit that it's following, indefinitely. In fact, I think they expect it to be basically ejected from that in about 500 years. So it's a temporary situation. But
it's permanent. It's permanent for us, but
well, that's right. As far as we're concerned, it is permanent. Yes. So there's the story then switches to artistic posters of the solar system. Believe it or not.
This was originally discovered by a fellow at Lowell Observatory, Brian Skiff, who noted it and reported it, and then went on to another job. And then out of the blue, someone rings him up and says, "What is this weird thing with the funny name?" And he scratched his head. He didn't really understand what they were talking about originally, because somebody else followed this up because of its weird orbit.
Yes.
And there was a bit of and that was based on a fellow who does a podcast who saw it on a poster on his son's bedroom wall. Is that how it goes?
I think that's the story. That's right. It's really, it's kind of quite an intricate story. And there is, in fact, the story is really well covered on the Sky and Telescope website, one of the most famous astronomy magazines in the world. And they've got a little piece out, a sort of a segment of that poster showing the planet Mercury, the sun in the middle, the planet Venus, and right next to it, this thing labeled Sulphur.
Sulphur, Z-O-O-Z-V-E, Sulphur.
That's right, Sulphur. And so that's where the mystery lay. And so, yes, word came back to, I think what happened was as you said, somebody got in touch, and that person tracked down the artist of the poster, somebody in Britain actually, Alex Foster, and basically they figured out that what had happened was that the name of the asteroid, which had appeared in a list of solar system moons or quasi-moons, it's 2002 VE. And 2002 VE is the standard International Astronomical Union designation for asteroids with known orbits. It's the year of discovery. The first character, V, is the basically the half month in which it was discovered. So it's A for the first half of January, B for the second half of January, etc. And V takes you to November, basically. So November 2002, and then the E on the end is just a sequence number, which is often followed by, a subscript digital number as well. If the thing has got basically, if there are enough objects within that V categorization. And in fact, Sulphur is 2002 VE68. So it was, the 68th asteroid discovery in the E category of the second half of November.
Blimey.
Yeah. So
that's complicated enough, but
it is, yes. Yeah, but that's the standard International Astronomical Union designation, and it's it's how we know of these things.
But the reason it became Sulphur was because
the guy doing the poster he thought his writing was so bad, or the guy who researched it found 2002 VE68 on a list of asteroids, wrote it down with his handwriting, and that the twos were like Zs, and so it suddenly became Sulphur, which is extraordinary, and
that's funny.
Why it appeared on the poster.
Yeah.
Now, I guess would you name it that? The answer is
That's become the question, because
yes, that's right. Yeah,
Zeus was a typo basically, or a writo, because he wrote 2002, and then when he came back to it later, thought they were Zs, so Zuzva instead of 2002 VE. But yes, they are looking for a name, apparently, a proper name.
Yeah, that's right. And the thing is that Zuzva won't work because the IAU have conventions about the naming of objects. And this falls into a category of objects within the orbit of Earth, which are named after mythological figures. And so it will be something different. When you name an asteroid, a standard sort of asteroid, then you basically the discoverer can give it a name, and it's got to be named after a person, or again a mythological figure like 5691 Fred Watson. That's good old Rob McNaught named that asteroid after me, which was delightful.
That's a great mythical figure, that one.
It is, yeah, that's right. But so like Krunia's a Celtic god name. So that follows, that's the one that's associated with the Earth. So it will have to be something like that, unless somebody can dig up a mythological figure by the name of Zuzva.
Well, it's close to Zeus, but I think it's already done. It's been taken.
Yeah, yes, that's right. You've suggested one of the things that people don't want. The one I liked was quasi-moon.
Sorry, what was that one?
Quasi-moon, not Quasimodo. But you highlighted the one that was probably on everybody's lips, which was
Moony Moonface.
Yeah, that's right.
But I'm very disappointed to say that they've already written that one off as a definite no-go.
I think they would have, yes. So it'll be really interesting to see what actually happens. And I hope it, by the time we get to 500 years, when it's no longer in that, I hope they've got a proper name for it by then.
Well, if it takes them that long, they might as well not bother.
Quite so, yes. But what an interesting story. What an extraordinary thing.
Yeah, so it's a moon that's not a moon in an orbit that's not an orbit around a planet that's not actually got any moons, and it'll only be there for 500 years, and we've botched the name. That's basically the story.
It's a disaster story, really. That's right.
Now, I looked up the size of it, Fred, and it's I don't understand the information, and now I've lost it, of course. But let me just see if I can find it again. Okay, 2002 VE68. It says I think it's tilde 118 is its size. Now I think that's based on kilometers. Let me see. Yeah, radius in kilometers.
Yeah.
But they've got the tilde symbol 118.
Tilde is shorthand for of the order of.
118 kilometres.
Yeah, of the order
that
of 118 kilometres. Yeah, it's quite big. Yeah,
right.
It's quite a long way away. It's sort of hanging around Venus, not orbiting Venus, but hanging around. So yes,
there are lots of them out there, aren't there? When you go through the list of known asteroids and quasi-moons, I mean, quasi-moons are a fairly recent discovery. We didn't really know much about them until recently, and Earth's had a couple. I think there's some of the gas giants have had their fair share. This is the first one we know of that's stuck itself to Venus. Well, it's stuck itself to the sun. It just happens to be hanging around Venus because it was lonely, I think. But yeah, they're not that common, really.
No, that's correct. And I guess why we're seeing more of them, well, partly it's due to the fact that we are now discovering far more of these small solar system objects than we were 30 or 40 years ago. And that's largely come from work, once again, by people I was associated with in Edinburgh, as well as overseas in the United States. The realization that the Earth is surrounded by this population of near-Earth asteroids, some of which might like to be in the same place at the same time as the Earth. Plus the fact that we've got now, quite extraordinary computing skills. So my master's thesis is on asteroids, Andrew, which I wrote in 75, I think, or something. And we were just starting to use big mainframe computers, which were only newly available to the academic community then. And even my thesis was all about the software, apps we'd call them now, but it was programs to solve the orbits of asteroids. And all you ever got out was a bunch of numbers. And it wouldn't have been that obvious if you'd found something that was kind of in one of these resonances with another planet, like Jupiter is with Venus. It would not have been something that would have been immediately noticeable. It's in this modern era, and I guess it's been modern since 1980s, of graphics and the way we can display things graphically, and you can immediately see if there's some sort of resonance going on there that you probably would have just overlooked back in the day.
I just looked up the quasi-moon of Earth, 2023 FW13. They reckon we're stuck with that one for 40,000 years.
Yeah.
That's what I read. Yeah, so that one's going to hang around a bit longer.
It's a stayer, is that one?
Indeed. If you'd like to read the story about 2002 VE or Zuzve, it's on skyandtelescope.org. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a short break from the show to tell you about our sponsor, NordVPN. And I've spoken to you many times about a virtual private network and the benefits that it gives. And I do personally use NordVPN. And yes, I did pay for it, just in case you're wondering. A few people might ask. No one has, but you might. But yes, I did pay for it. I got the 2-year plan with all the bells and whistles. So I've got everything that comes with that service, and that includes the virtual private network. My favourite part, which I've told you before, is the password protection system, which stores all your passwords and your usernames and all the information in one handy location, so you only have to remember one password. I particularly love that. One of the other tools in there, though, is the next generation file encryption. Now, this one sort of works in the background, and it does a really fabulous job. It basically generates ciphers and cryptography algorithms to keep your files, your identity data, your digital signatures safe on your device and on the cloud. The other thing I like about NordVPN is it works on everything. It works on Windows, it works on Mac, it works on Linux, it works on Android and Apple devices, it works on Windows, it works on Firefox. Basically, any browser system you've got, you can load the NordVPN system into the browser proper. And so it's always working away in the background. Of course, VPN services are fabulous for public Wi-Fi and any situation you find yourself in where there are lots and lots of people around using Wi-Fi. You just never know when somebody will be there to try and, hack your systems and take your personal data, whether they're stealing your identity or stealing your money. It could be both. But the deals that are getting done on the dark web to create fake identities using your information is just out of control at the moment. And you can protect yourself simply by getting a virtual private network, and there is no better than NordVPN. And I certainly do endorse their product. It's the best in the business, and they guarantee high speeds from all their servers. You won't lose anything in the translation. The URL you need for this, and don't forget their 30-day money-back guarantee, is nordvpn.com/spacenuts. It's an exclusive deal for you as a Space Nuts listener. nordvpn.com/spacenuts. Once you get in there, click on Get the Deal and have a read through all the products and the plans and see what works for you. nordvpn.com/spacenuts. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we're on the hunt for sulfur. Of course, it is a substance that gets mined on Earth for one reason or another, probably used in the medical world, but other things as well. But in the universe, There's supposed to be plenty of it, but up until now, they've not been able to find enough of it to justify the numbers, the mathematics in terms of all the substances in the universe. So what is going on with sulfur? We haven't really talked about it before.
We haven't. And in fact, this story centers on something else that we don't often talk about, which is the objects that we call planetary nebulae, which are nothing to do with planets. In fact, their name came from William Herschel, the great 18th and early 19th century astronomer who named many sorts of things, including asteroids. He saw these nebulae he didn't really recognize them as clouds of gas. In fact, nobody really knew what they were in those days. But he saw a misty patch which looked like a planet, and he saw several of them in the sky. And that's why mist is, it's the word nebula just means mist, and that's because the early astronomers didn't know that there were clouds of gas. We now associate nebulae with gas clouds, although in those days galaxies were nebulae as well, because all they looked like was misty patches. So these were misty patches, so they were nebulae, and yet they were quite circular in form, and hence were called by William Herschel planetary nebulae. And what we now recognize is that these are the sort of end products of stars, a bit like the sun. So this is kind of where the sun's heading over the next 4 or 5 billion years. Sun-like stars have a very long life cycle. They're born, they've got something like 10 billion years of maturity, where they're behaving like the sun is, in a very stable state, with the nuclear fusion in the center generating the energy that supports the inward pull of gravity that stops the star collapsing into a neutron star or a black hole. So they've got this balancing act going on. It's exactly what's happening in the sun at the moment. Energy being produced in the middle, finding its way outwards and radiating it as heat and light to us, with gravity trying to hold it all together so it doesn't just all dissipate into space. But at the end of that period, the nuclear processes change at the end of 10 billion or so years. And basically the star runs out of hydrogen, and you get a period of other reactions taking place. Helium burning is one of them, which is another nuclear reaction. And in the end, the star its core starts slowly to collapse, and its outer envelope starts slowly to evaporate or spread out into space. And what we eventually see is one of these clouds of gas that has very, very strong symmetry. Sometimes they are spherical. More commonly, they're pinched at the waist to form a kind of hourglass, which would be sort of along the axis of the star's rotation, and that's caused by gas outflows and things of that sort. But planetary nebulae are the sort of graveyards of stars with a white dwarf at the middle in the most evolved ones. So one of my another of my former colleagues at the UK Schmidt telescope, Quentin Parker, who I worked with over many years, he has had a long-standing research interest in these objects, and so he worked on them at Macquarie University here in Australia, and then subsequently, quite a few years ago, moved to the University of Hong Kong, where he's still a professor of astronomy. And he and one of his colleagues, Shuyu Tan, have actually observed a large number of planetary nebulae and think they've uncovered a mystery. And that's the sulfur mystery. And I'm just going to read from their paper, Andrew, which is being published in Astrophysical Journal Letters on February the 1st this year. And it starts off, sulfur should be produced in lockstep with others like oxygen, or like with other elements like oxygen, neon, argon, and chlorine in more massive stars. So its cosmic abundance, the amount of it, should also be proportional. Strong correlations between sulfur and oxygen abundances are seen in what we call H2 regions. They're particular kinds of clouds, and blue compact galaxies. However, historically, planetary nebulae sulfur abundances, which arise from low to intermediate mass progenitors, that means normal stars, have consistently been lower, giving rise to the so-called sulfur anomaly, first identified in Planetary Nebulae by Henry et al. 2004. So that's the paper. But what they've done, and this is actually reported in an article on the space.com webpage with the title that I love, Fire But No Brimstone. Where is the universe's missing sulfur? Because brimstone's the old name for sulfur. And what they've done is they've sort of reanalyzed the spectra of planetary nebulae. By that, I mean the rainbow of colours that when you look at it has this barcode of information on it, which actually basically tells us what the elements are that either the light has passed through or that that originated it. So we've got this barcode from which we can see. And what they've done is recognised that the measurements that have been made basically have been kind of leading us up the garden path in regard to sulfur. I'm going to quote from that really nice space.com article, which says, to crack the planetary nebula sulfur mystery, the team looked at 130 planetary nebulae located at the heart of the Milky Way, an unprecedented data set. Unpolluted with background noise or unwanted information. The data set is attributed to the Very Large Telescope, one of the world's most advanced optical telescopes, that is located at Paranal Observatory in Chile's Atacama Desert. And what they're saying is that the fact that they're using a big telescope like this to observe planetary nebulae has been the breakthrough, because they've been able to see details in the spectra that smaller telescopes wouldn't reveal, where you don't have enough light, so you can't split the spectrum up into its rainbow colours enough. And so, as Space.com says, what the team discovered in its data is that the lack of sulfur is simply the result of poor quality data for the light emitted through the planetary nebula. Using the large sample of the planetary nebulae with its high signal-to-noise ratios, the researchers saw a strong lockstep behaviour between sulfur and the other elements for the first time, with the previous anomaly effectively disappearing. So what this tells us, Andrew, is quite an interesting aspect of it. So Quentin Parker and his colleagues working on these planetary nebulae, beavering away for decades, actually, at what you might call a fairly unpopular, not unpopular, but perhaps unfashionable area of astronomy. Planetary nebulae, to many astronomers, yes, they form part of the big picture, but they're well understood. We kind of know what we're looking at when we observe them. We know we're seeing the debris of chemicals that have been generated in the star's outer envelope that has eventually cast it off and formed this shell around it. And because of that almost humdrum nature of planetary nebula studies, nobody's turned a big telescope onto them until now. And good on Quentin and his colleagues for getting the telescope time to do that, to observe planetary nebulae. And they've done it very successfully, and they've actually solved a mystery. So I think that's a step forward.
So it's always been there. We just haven't had good enough data to pinpoint it.
That's exactly right. So it's not something that's appeared out of nowhere. It is, it's basically the result of using better facilities to observe these objects than we've done before. But just to wrap it up, though, they point to the future because Quentin Parker and Shuyu Tan end their abstract in their paper by integrating these findings. We provide a plausible explanation for basically they mean the eliminated sulfur anomaly, and propose, actually they're saying that there is a residual anomaly that they can now identify, but they propose its potential as an indicator of relative galaxy age compositions based on planetary nebulae. In other words, they're pointing that what they're saying is, and I've garbled that quite a lot, so I apologise, especially if Quentin's listening. They have their observations are so fine that they've identified things that have bigger applications. They've found perhaps little windows into or fingerprints that might reveal other things about planetary nebulae that we didn't know before. So they've sorted out a problem, and they've also pointed to new possible discoveries in the future.
Okay. Of course, when we think of sulfur, we think of volcanoes, because if you go to volcanic vents, you find they often have little yellow patches around the vent, and that's sulfur. And as I said, it's mined. They use it for making car batteries and fertilizer and refining oil, processing water. It's also used for rubber vulcanization and bleaching paper and making cements and detergents, pesticides, and even gunpowder. It's pretty good stuff. It smells like rotten eggs, but it's pretty good stuff.
It's good stuff, yeah. And now they've solved the planetary nebula sulfur anomaly, so it's even better.
Yeah, it's everywhere. It's everywhere. All right. If you'd like to find out about how they discovered sulfur and the fact that it's always been there, you can go to space.com. There's a great story about it there. That wraps it up, Fred. Just a reminder too, if you want to listen to Space Nuts Q&A, that will be coming up on Monday. It'll get downloaded to your respective platforms automatically if you're subscribed to us. And if you're a follower on YouTube, don't forget to hit the subscribe button below. Thanks, Fred. We will catch up with you real soon. Fred Watson, astronomer at large, and he joins us every week on Space Nuts. And I hope you'll join us again very soon. We'll catch you then. From me, Andrew Dunkley, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.